guys, this video is going to be all about physical and chemical changes. So you guys should know by now that chemistry is all about the study of matter and its changes. So we've defined what matter is at this point, and so now we're going to start talking about ways that matter can change. All right, so let's come over here and we're going to start with kind of properties of matter. So one thing we definitely need to be able to do in chemistry is we need to be able to describe matter. And so for right now, we're going to stick with really simple physical and chemical properties. So let's define physical properties. So physical properties are things that can be observed or measured without changing the arrangement of atoms. We also call that the chemical makeup or the chemical composition. So they can be observed without changing what our atom is actually made of or the arrangement of our atom. All right. Now I do want to make a note, guys, that or not yet, just kidding. I don't know what I'm talking about. So some examples of physical properties are like color, size, length, the mass, the volume, density, texture, malleability, ductility. These are all physical properties. Yes, I feel like I need to sneeze. Okay, it's not happening. So yes, so those are all, just kidding, it did happen. Cool. So those are all physical properties. So we can see all of these without changing them. Like color, you can just look at something and see the color of it. Whereas like mass, I can stick something on the scale and it doesn't change the chemical composition of it just because I stuck it on the scale. So those are all physical. We don't have to change them. But then we have chemical properties as well. And for our chemical properties, the atoms must be rearranged to observe them. Oh my word. So examples of these are like ability to be oxidized, means like rust, to be rusted. I can't just look at something and be like, oh yeah, that's gonna rust. I actually have to see it happening to know for sure that it's gonna rust. Flammability is another example of a chemical property. While I currently have a pretty good idea of, and you guys probably do too, of what kind of things are going to be flammable and what kind of things are not going to be flammable, you actually have to observe, it catching on fire to know for sure if it's going to be flammable. Reactivity, so will it react with other elements, and what type of elements or compounds will it react with? Because I'm sorry, my thing is having issues today. And toxicity and acidity. These are all kind of examples of chemical properties. Okay. Now then, in physical properties, we actually have a further breakdown. So we have intensive and extensive physical properties. So again, these are both just for physical. All right. So in extensive properties, they depend on the amount. So it depends on how much matter is involved. So what that really means is that your extensive properties are going to change. Change when your amount changes. So examples of this would be, your mass. The more you have, the more it's going to weigh. The less you have, the less it's going to weigh. Volume, again, the more you have, the more space it's going to take up. Size may change. Length could change depending on how it happens. But yes, those are going to be extensive properties. Depends on how much matter you have. And then intensive properties are, again, these are only for physical properties, not chemical. They are independent of amount. So intensive, independent of amount of matter. So these are things that aren't going to change even when our amount of matter changes. So for example, your color, no matter how much you have, your color is going to stay the same. Your texture will stay the same. Another one that kind of trips people up a lot of times is your density. The density does not change based on amount of matter. So density will be the same. Your odor won't change. Malleability won't change. All of those things. So just ones that won't change if you add more or less. Those are still the same. Okay, so what we've talked about so far is how we can describe matter. And that's great. Describing it is fine. But what's really interesting is how does matter change? So chemistry is all about changes in matter. So you're doing chemistry when matter is changing. And it changes in two different ways, physically and chemically. So physical changes are boring, not super fun to watch. But basically, it's a change that occurs without altering the chemical composition. So for this one, I do want you guys to make a note that the appearance may change. Ooh, my goodness. Come on. But we still have the same substance. So you may have a different appearance, but the substance is still the same. Okay, so let's go through some examples of these. So examples is like cutting paper. Your shape of your paper has changed, but it's still paper at the end of the day. Breaking glass. So if you drop glassware or something like that, it's still glass. It's just now in lots of different and tiny pieces. And then another one that people often don't realize, though, is a physical change, is phase changes. So going from like solid to liquid to gas, it's still water. It's just water with slightly more energy. So phase changes are also physical changes. And guys, physical changes are typically pretty boring. Like watching someone rip a piece of paper, super boring. Okay, so that's a physical change. And then we have chemical changes as well. And chemical changes are changes that occur that form a new substance. So in a chemical change, we are actually changing what we end with a different compound than we started with, basically, or different compounds than we started with. So examples of this is fire, digestion, like fireworks, any kind of chemical reaction. Rusting is a chemical change. Hopefully you guys have lots of ideas of chemical change. So while physical changes are pretty boring to watch, chemical changes are typically much more interesting and more fun to watch. See what I mean? Okay, moving on. All right, so we have 6 indicators of a chemical change that you guys should know. And you guys have probably heard of most of these before, so they shouldn't be super different or crazy from things that you've previously learned. So I always like to say, though, for these indicators of a chemical change, that they are all a surprise. So some of them don't count if you know it's going to happen. So let's go through them. So one of the first ones that probably a lot of you know is an unexpected color change. So this would be like when I mix, a clear solution and a blue solution, and I end up with a yellow solution. It's pretty unexpected. Wasn't ready for that. So an unexpected color change is one indicator of a chemical change. Another one is an odor change. Typically, if we have an odor change, that means that some sort of gas is being produced. All right? Another one we see pretty frequently is a temperature change. Our chemical reactions, we may mix 2 things together, and then all of a sudden it gets really hot or really cold. That would be an indicator of a chemical change. But this is where the surprise is kind of important. Guys, if I put something on a hot plate and it gets hot, it's not that shocking. So this is where the surprise aspect is pretty important. All right, number 4 would be bubbles. If we see bubbles, and bubbles also tells us that there is a gas being produced. Number 5 is one that you guys may not have heard of before, but it is a precipitate. So a precipitate formed. And a precipitate, I have some bad handwriting here. Precipitate is a insoluble solid. So insoluble means cannot dissolve. So insoluble solid. And then finally, our last one is we have light given off. So it's going to be really important that you guys know those 6 indicators of a chemical change, because it's how we can determine if a chemical reaction took place or not. All right. Last thing is we are going to do a little practice. So we are going to identify these as a chemical property, chemical change, or physical change. Now, guys, remember, change has to be an action. So something has to happen for something to be a change. All right? So the first one is odor of a flower. Okay, well, odor's not an action, so it's definitely a property. And odor is going to be a physical property because I can smell my flower without, changing the thing of it, the composition of it. Water heated and changed to steam. So stays water. It is a change because we have an action there, but it's still water the whole time. So this is going to be a physical change. All right. It just says copper turned green. So here we see that unexpected color change. It did have a change in it. There was an action. And so this one would be a chemical change. Burning your homework. Not that any of y'all would do that, but burning our homework would be also a chemical change. All right, I'm going to do a couple more with you. reacts with water. So it's just a description saying that it will react with water. So it's not an action saying that it does. And so this one would be a chemical property. All right, go one more. Bleaching fabric. When we bleach fabric, we do actually change the chemical properties of it. So this one would be a chemical change. Now I want you guys to try to do the rest of them on your own. All right, so pause the video, try to do the rest, and then we'll go through them pretty quickly. Okay, let's go over them. So, making Kool-Aid. Guys, dissolving is actually kind of debated. So, it could either be chemical or physical here. Kind of debated in the scientific community what happens there. Ice melting is a physical change. Milk souring is a chemical change. Iron is magnetic is a physical property. Silver is shiny is a physical property. Fireworks exploding is a chemical change. Lemons taste sour is a physical property. Candle melting, physical change. If you're talking about the actual melting of the wax, if you're talking about the burning of the candle, which is the next one, that is a chemical change. Dog tears your homework, physical change. Ice turns into water, physical change. Gases produce chemical change. And then magnesium can be flattened. It's a physical property. Okay, guys, that's it. Hopefully you feel pretty good about physical and chemical changes and properties. Feel free to email myself or Mr. Oglesby if you have questions. Bye.